construction of our crazy project with unique shots that were not included in the main series. We fit a whole year of work in one video. Time will tell what will happen, and we will begin. Enjoy watching. So this is the beginning of our next crazy project, which will be based, or rather stand on, a Ford test. More precisely, what is left of it. Alan Kokoev made two options. Here is his Instagram. The first with a roof from a Volga, and the second with a roof from a Bugatti. Without thinking twice, we settled on the second option. It's clear that we didn't buy a Bugatti in order to take the base and rear end from it. And Ford was not chosen by chance. The wheelbase is almost the same as that of the Bugatti, and for the rest of the dimensions it also fits perfectly. The next step, we went in search of the 21st Volga. I found a good option in a neighboring village. We load it on a tow truck and take it to the workshop. Since we only need body panels, the technical condition has no role, and therefore the body was bought for parts. First of all, we throw off the hood, first from the Volga and then from the Ford. Since there is no clear instruction on how to combine a Volga with a Bugatti based on a Ford at this stage, everything is done in advance and with clamp. We firmly decided that we needed to reposition front wheels in order to get a result as close to the concept in the picture as possible. There were a lot of suggestions to just shift the arch, but that's not an option. Here's a clear example of what it looks like when you just shift the arch. So our friends helped us with this issue. As you can imagine, it is not an easy job to shift the wheels by 6 inches on a front-wheel drive car so that it drives smoothly afterwards. It's not the first time guys have done this. They've done a lot of cool projects, including remodeling ordinary cars into drift cars. In the end, every car was driving great. In our case, that's exactly how it turned out. First, the struts were moved. Then step by step the engine and suspension were moved forward by 6 inches. The guys helped us a lot, and the rest is up to us. We'll have to do the wiring, figure out how and where to put the radiator in, but I'll come back to that a little bit later. The main thing is that the wheels are in the right place, the car steers and drives straight. We put the hood clearly in the center and decide to base on it. We took the native loops from Ford and connected them with the landing pads of the Volga's bonnet. The result is a simple design and a removable hood, which is very important. When the hood is in place, we throw off the remaining front end elements from the Volga. In order to integrate the grille, fenders and bumper, it's necessary to remove all unnecessary that goes beyond the dimensions of the Volga S panels. And after an hour of trimming and fitting, we put on the fender. In general, everything worked, and we can say that it was rather easy than expected. Now it remains to make the platforms on which the fenders will fall. For this, a square profile was taken, and then everything is clear. Without further ado, after half a day of work, we have such platforms that are perfectly symmetrical with each other, which in principle can be seen when the hood is closed. The next step is to patch up what has been unpatched. A bit of sheet metal, couple of hours of welding, and in general everything looks more or less neat, almost like a factory. In order for the hood to close and open, we again go to the donor and carefully uninstall this panel on which the hood is located in the original. It's clear that the Ford lock will no longer be useful to us. Therefore, we remove it and put it on the distant shelf. Then many hours of fitting, and for you it's only a few minutes. When we have clearly decided on the location, we attach the grille to this panel for ease of positioning and tack it with welding. In order to close all the gaps between the Ford and Volga panels, we make a dozen cardboard templates, which we then transfer to the metal. And the metal in turn will be transferred to the body. When all the patches are ready, we fix the shelf with a hard wire and we begin to patch. After half a day of welding and the same amount of cleaning of the seams, we have the following result. Everything is clear, rigid, and made of metal. It will remain to putty and prime everything minimally. The Volga bumper at the factory rests on this strange panel, and we mount it to the Ford body. When the main power elements have taken their places, you can do a preliminary assembly and already a little understand what we have. According to the factory, Bugatti slippers are size 20, real Italian 20s wheels from OZ. So we lifted the car, put it on a rack, removed the old wheels, and here's for comparison, as they say, before and after the donation. When the wheel plates fell into place, it became clear how many inches are they from the hub, which means we can order spacers. What is it and how does it work? Using these plates, which are ordered individually, you can put any wheels on any car within reason. Also, spacers are often used to extend the wheel plates, and in our case, they're 2-in-1. That is, we put wheel plates that initially did not fit and extend them out by 2 inches. As a result, we get the wheel as in the picture. Trying on spacers, it was hard not to notice the terrible state of brake discs and pads. I don't think it's worth explaining the importance of the braking system. Therefore, where possible, we want to achieve maximum reliability. The brake pads were also replaced. We've more or less figured out the front, but things are more complicated with the rear. After a little thought, we decided to buy a Bugatti. Yes, the same Bugatti Chiron in a 3D model. It cost us only $25, and here's how it looks. We'll make a body based on it. I mean the part of the body that we need for the project. So to speak, non-waste production. In the 3D model, we cut the body in parts and then cut the panel into thinner ones. Each such panel should not exceed a thickness of 4 inches. So, why did we divide all the parts into 4-inch thick panels? This is due to the length of the cutter, the stroke of the spindle, and so on. And based on these technical features, we came to the conclusion that it is easier to cut many panels with a thickness of 4 inches and then glue them into one whole body. How does it work? We put a sheet of polystyrene on the CNC. The sheet size is almost 47:24, and starting from the given program, we start bas-relief cutting for many hours, sheet by sheet. After a few days of sharp milling and sampling, we move on to the next stage. First of all, we release the blanks from the sheets. At first glance, you might think that there is a lot of waste and one more body of some Smart could be cut out of them. Yes, a body of a Smart would fit here without any problems, but the elements of Bugatti can't. Believe me, if it was possible to arrange the parts more economically, we would do it, given the cost of materials recently. So, we cut out everything superfluous with a knife, and an hour later, we have such a pile of Lego parts for adults. At first glance, it seems that it is unreal to sort out this chaos, but trust me, if you spend a couple of days at the computer, thinking how to cut the body correctly and into what parts, you'll know each part by name and determine it even with your eyes closed. The whole thing will be assembled using polyurethane glue. It looks like mounting foam, but unlike it, the glue does not increase in volume. To avoid waiting until the glue seizes on the previous layer and for better fixation, we screw all the elements together with self-tapping screws, part after part, hour after hour. After 2 days of work, we have 3 main separate elements, a roof and 2 sides. All there's left to do is to connect them and get a solid structure. Here's how it looks. We adjust the junctions with a grinder with a pedal circle. We apply the same glue and then we screw them together with self-tapping screws. The next day, when the glue is dried, we have a one-piece body, and now we can clearly see the parts that need to be improved. We fill such holes with the same glue. We wait until it dries, cut off the excess, and move on. Now we can finish the form, which is what Andre is doing. Flexible planar various lasts a couple of days of work, and 10 years of experience will make a shape close to the ideal, as far as it is possible to do it with expanded polystyrene. The next step is to prime and putty the form in order to make its mold later. Most often this operation is replaced by pasting with metal tape, and the matrix is made by it. We use a slightly different technology. Rather, it's a matter of habit, but it's easier for us. The first layer is priming. In our case, it's a simple water-based paint. Yes, the one that is used for painting walls, and this is important as any other resin or solvent-based material ruthlessly corrode expanded polystyrene. Here's a good example. Just imagine, let's say you made a car body, cutting it out, gluing it, finishing it for a couple of months, and finally, the long-awaited final primer. You primed it, and after 15 minutes the body is gone. That is why at this stage we use water-based materials. In addition, they are much cheaper than professional 2-component materials, and they are just perfect for these purposes. After we applied the first layer, all the spots that need to be putty appeared. The putty used is also 1-component water-based. Yes, the one that's used to putty walls. The next step is the developing layer. Most often the base paint of a dark color is used. It is applied around the entire perimeter, and later when grinding, all craters, chips, indentations, and rough stripes from sandpaper are clearly visible. Along the body are such thin longitudinal lines. They are also above the arches. To keep them crisp, thin, and elegant, we need to line them properly. Masking tape is glued along the line, and starting from it, planes are lined. The main thing here is to stick the tape correctly and evenly, otherwise you might line something that was not planned. Well, then a few days of grinding and a couple of pounds of dust. we did was to determine the places where matrices would attach and detach from each other. That's where we made the edge. That is, the entire structure will consist of many rigid elements which will be assembled into one large integral matrix with the help of bolts. This edge will be the connection point. It is made of plastic, piece by piece. We were fitting it to the shape of the body and tacking it on the hot melt glue. The Bugatti has a mohawk in the center of the roof. It will be very difficult to fit it into the matrix. It is much easier to make it separately, so at this stage we remove it. Then we do the flanging. It's already clear now how it works and into which elements we divided the body in order to get the fiberglass part out of the matrix without any problems in the future. The first layer is the release agent, tinted blue, so that it can be clearly seen where and how much of it is applied. This is a release agent based on white glue. It is considered single-use, unlike wax. But in our case it works better, because we are not planning to make a line production of bodies for Bugatti. And in terms of time, this release agent is much faster than applying wax in several layers, polishing it and so on. So, for a single copy it is easier to use this kind of single-use release agent. We applied the release agent to elements that are not adjacent to each other, and this was made for a reason. A little later you will understand why we did it that way. Then we taped the adjacent elements with a film in order not to spoil them with compounds that will be applied on the blue areas. The next layer after the release agent is gel coat. In the white compound, we add a little bit of the same one but black. Then we add the activator and we get a gray gel coat which is applied evenly with a brush. We made it gray so that it is visible where and how much of it is applied. Also, the difference in the two colors allows you to see how well and evenly mixed the compound. This is very important, so it has to be well mixed. Basically, this is the first layer, which will be the front layer after we finish the work. The release agent will be removed as a thin film. The next step is to apply glass fiber mat, covering it with polyester resin. We do this when the gel coat has already hardened. You cannot press it through with your nail, but it is still sticky like Scotch tape. That's when you have to apply polyester resin so that all the layers are well joined and stick together. It's pretty the same story here with polyester resin. Polyester resin is a two-component compound, so we mix A plus B nicely and apply the first layer with a roller. Then layer by layer we spread the glass fiber mat. We used the material with a density of 150, 300, 450 and 600. These are grams per square meter, but we used 150 density glass fiber mat only in the most difficult, delicate places where it is complicated to spread the thick material evenly. So basically the work started with 300 density and then everything is clearly seen: a layer of glass fiber, polyester resin and a roller. But you can't spread out a couple of layers at once. According to the technology you can spread out the next layer the next day, as polyester resin is strongly heated during polymerization, and if you make a thick layer of it, this compound would deform when heated and can easily deform the framework on which we applied it. And of course the polyester resin shrinks as it dries. If you apply it layer by layer, it's not a big deal and it's unnoticeable, so we did it this way layer by layer, day after day. And in the end it took Andre almost 2 weeks to do this work. Each layer is well coated with resin and rolled with a roller. In the end we used this metal roller with needles to remove all the air that remains under the glass fiber mat. Before applying the next layer we run a coarse sandpaper over the entire area to remove the obvious roughness and needles from the glass fiber mat. In the end, in order to create a more or less rigid matrix form, we put 2 layers of 300 mat, 3 layers of 450 mat and 2 layers of 600 mat. It took 132 pounds of polyester resin, 9 pounds of gel coat and a lot of workdays for Andre. So why did we tape and zone the areas? As you remember, at the joints, we have plastic edges. We've already put glass fiber mat on them from one of the sides. Now is the time to remove the plastic. As a result, instead of a flimsy plastic edge, we have a rigid edge which is an integral part of the main element. Now all that's left is to put glass fiber mat on this side as well. And we will get the right design, but once again a surprise was expecting us. In some places the resin has found way out. We peel off the top layer of gel coat, clean up and putty the spots where the resin has eaten away the workpiece. The rest was done in the same way. A few days we covered it with the glass fiber mat layer by layer, and now we have a finished matrix which should be detached, and then we'll evaluate the result. The first thing to do is to cut off the sharp edge with a disc grinder. The next step is to drill holes around the perimeter. Later, during assemble process, we'll insert bolts in the holes and it will be possible to tighten all the parts of the matrix together. And finally we start to disassemble the construction. As you see, the edge has been lubricated with a release agent, and now it has a clear border which perfectly adheres to each other. The second edge was applied in a liquid state and perfectly took shape. Basically that's what you see on the screen. In the end we didn't manage to keep the expanded polystyrene blank intact, although no one really tried, because after gluing it we realized that it's impossible to take it out of this room. There are only 2 small doors. Well, if we fold the expanded polystyrene body into the trash bags, it goes perfectly through the door. As you can see, the construction was large, complex, and rigid, so we disassembled it by all available methods. In the end, the matrix is ready. It is good.
So, we assembled the matrix and prepared it for the application of the parting agent. Now we can use wax. We leave it here for 5 minutes. Each time we're gonna polish it. The wax works as the parting agent, so that after putting all the layers we could easily take out this large and complex form out of the matrix. And now we have to use the method of applying 5 layers of wax. We need to polish the wax properly. As the competent people say, we have to use soft rags.
Okay, what is the next stage? The first layer is gel coat. Roughly speaking, it's a special primer that is gonna be the facing layer of our body when we get it out of the matrix. What about the next step?
The next step is to apply the glass mat. In contrast to the matrix, we're gonna gain the thickness right away. We're gonna use 1 layer of glass mat 300 and 3 layers of glass mat 450. The estimated thickness of the piece is about 3 millimeters. You've seen this process several times. I suggest we shouldn't dwell on it. Let's move on to the fun part. We unpack the matrix and get a solid fiberglass bodywork. And by the way of footage to prove how solid this material is.
And then we unscrew 50 bolts and get to the unpacking. You can clearly see why the bodywork was divided in several pieces and was isolated this way. In the end, this complex solid form is disassembled easily and we have a finished body. We just need to get it in another workshop 6 miles away. But before that we cut off all the excesses and the remaining glass mat. After that we polish the sharpest places. We're doing right now because we want to carry this body with our bare hands from one place to another. If you cut your finger with or got a splinter of glass mat once, you know exactly why. All in all, I think the fiberglass bodywork is quite a decent technology. One of the main advantages of it is that this body will never rot or rust. By the way, the experiments with plastic car bodies was conducted back in the 1950s. And the first production car with fiberglass body was Chevrolet Corvette in 1953. Just imagine, 70 years ago. But this material has disadvantages, of course, but that's a topic for another video. And in this case, this is obviously and simply the right option. Many know that in addition to creating unusual cars, our workshop also creates smart tables. Finally, we decided to make it for sale. Of course, no business can be successful without a working and usable website. It's possible to make such a website in approximately 10 minutes on the platform Squarespace, the sponsor of this video. For this you need to choose template and customize it for yourself. In a few clicks you can personalize your site. And what I like about Squarespace, the ability to see how the site will look on different platforms. It's easy to make changes and you don't need to be a programmer to set something on your website. Number of ready-made templates over 100. All of them are free and available in a choice. Also, all these templates have adaptive layout. All are made qualitatively and correctly displayed in all types of different devices. There's no problems with editing the site. Everything is clear even for novice users. Editing content may be performed by man not familiar with the layout of web pages and programming. The Squarespace base has many controls, animation, fonts. All this can be customized for yourself to create individual style that no one has. You can save 10% using code AccessGarage when ordering. So the next stage is to cut everything that prevents the fiberglass shell lower, but first we take off everything we can until we have just a naked bodywork. This is what the guys are doing. By the way, this is an unusual way to attach a bumper, 3 rivets, a metal plate, and the car gets perfect gaps. It wasn't hit, wasn't painted. We should give credit to the previous owner because the condition of the body is really great. In the first video I've told you that we bought this car partially disassembled. This was an unfinished project, but the work on the body was almost completely finished. Considering the fact that it's Ford and it's from 1992, we can say that the body in a perfect shape apart from a few parts, but we're gonna fix them. We removed this torpedo dashboard, and now there's just one little thing. We're gonna remove the heater, all the cables and wires, because we're gonna do a lot of sawing, cutting, and welding, and all this plastic will hinder us greatly and we can accidentally burn it. Before cutting off the roof we need to cut out the windows. It's a pretty easy task, we only need 1 string and 2 bass guitar players. As for the rest of the interior, they removed everything from here before us. We bought this car like this. The previous owner repaired the body, painted it, but then he stopped working on it. In fact, this happens all the time when a car restoration project lasts for a couple of years. All in all, it's not about the skills or the experience. Most commonly the enthusiasts lose interest in their projects and then it's quite hard to resume the project you've abandoned for a year. I think anyone who was in this situation will know what I'm talking about. And in the end these projects end up on Craigslist or similar websites and the ads say, it's almost completed, you just need to assemble it. And we bought it to disassemble it even more.
After a few hours of work, we have an almost completely cleared body. So, the next step is to saw the roof off, because the moron who created Bugatti made it such a way that we can't put the roof on top of it, and since the angle of the back window is completely different, that's why to stop the body from collapsing when we saw the roof, we create improvised braces of the body.
Yeah, these braces are very important. The car really collapses if it's not a framework or convertible type of car. They work in a completely different way and the body is designed very thoroughly. But our car is not convertible, that's why we installed the braces. Okay, that's it, we strengthened the bodywork, now we get on with the sawing. The next step is to draw an arbitrary line and the show begins. Then we use every tool that can saw, cut, or affect metal in any way. The Bugatti S body is shorter than Ford's body, and in order to put the fiberglass shell on it, we have to shorten it. We put it on and realize that it doesn't fit at all. It's not hard to lower a car by adjusting the suspension, and before installing the new suspension, we need to make sure if it will fix the problem and if we can install the bodywork forward if we set the car as low as possible. To do this we put the car on the pads, trying not to drop it on the ground. For the next hour we were busy picking proper pieces of wood, meanwhile measuring the gap with a super precise tool. The foot of our former sponsor. Here, there's our Bugatti. This is our Bugatti. After the specialist approved the height we put the bodywork on. Now it's all become clear and the lowering the car solves this problem. To do this we've decided to cut off the coil springs and they order coilovers and do it properly. That's exactly what we did in the end. We cut off the coil springs to install the wheel properly. We put what's left of the shock absorbers back and then it became clear that the arches don't fit to the clearance.
Right now we lowered our car with improvised means without coilovers. We're gonna have round arch, just like in the picture. And to keep the work going, we're gonna weld the arches again. I think it starts to look pretty cool, we really like this picture.
The degree is right, it's going great.
So, let's weld some arches. After a few hours of work, we can see the shape clearer. The top of the Volga part has this nice round edge, and now we're gonna try to replicate it with improvised means. We install the arch using screws.
and then it just falls into place. We take out the temporary screws and put the permanent arch on the temporary fender. Since these metal body parts will be covered with pounds of plaster, we're gonna perfect it and create a matrix, and then we create all these elements from fiberglass. In the end, we're gonna get fine and light panels that will perfectly fit to our tasks, but it's just a theory. In practice, we're gonna remake them several times. So at the first glance it looks pretty weird. The thing is that it lacks decorations that makes a car look the way it's supposed to. For example, this is how the appearance changes when we put on a minimal set, a front bumper, a sill, and drag the wheel where it should be. And that's when I had a sigh of relief, because I 100% pleased with the proportions. That's the most important thing. The rest part of the work is to finish the body and a few other things. Yeah, it's not that easy, but it's just a matter of time. And to get the right outline was our main task. Meanwhile, the work on the racks doesn't stop. After 2 Valera hours and 1 Andre day of measurements, which in fact is the same thing, it became clear that it would definitely not work to fit the donor's windshield struts to the Bugatti body. Therefore, we cut off all the excess and separate the racks. We decided to make the arc like this. We took a simple plastic form. We checked how it would look and what we need to change. That's about how we figured it out. So we realized what angle we need in order to get here this smooth, beautiful shape, which is such an integral feature of Bugatti. Therefore, we took plastic and the boys had to make it out of metal. As you can see, this is done manually. The main task here is to get 2 absolutely identical arcs for the body to be correct and symmetrical in the future. Therefore, after each operation we compare one pipe to another and adjust them based on the result. We estimated this shape by eye and based on the height of the car which we need to get in the future. A few hours later, we have a pipe of this shape which is firmly inserted into the cavity of the factory pillar. We merge them slightly by welding and check the symmetry with a laser level. We understand that everything is okay, so we can weld everything well. We also thoroughly weld the pipe in the front. In such hard-to-reach places it is difficult to weld everything well, but with the help of an angle grinder a hard-to-reach place turns into a very easy-to-reach one and we can continue welding. In the back we weld the pipe in the region of the strut mount to a pre-reinforced platform. The next step is to thoroughly weld the structure at the cutoff point of the factory pillars, simultaneously adjusting the metal. Well, and so on both sides. After everything is tightly welded, we take control measurements, adjust the shape with a jack quite a bit MTRY on the template, and in general we are very pleased with the result. The shape of the shell and the arches fit together perfectly, and this means that we can safely finish the bearing frame. It would be more correct to call it a safety cage. Most often such a thing is done in racing cars, and it is needed in order to save the living space of the car crew in the event of an accident. And it is also used for longitudinal reinforcement of the body. Initially, safety frames were used in rally races, but later their use became mandatory in other disciplines. It is made only from round pipes since round sides are less traumatic. Depending on the complexity of the frame design, different reinforcement options are possible, starting from simple ones, these are arches over the heads of the driver and passenger, and ending with complex ones, a spatial skeleton that combines the front and rear suspension cups into one power structure, sills and sidewalls, as well as the safety cage of the car interior itself. This is exactly what we should get. Here's a good example of how such a frame works and saves lives. Of course, we're not going to participate in races, and we are making the frame only because we have completely cut off the upper part of the body, which did not fit into the project at all. Now we need to marry our pillars with a frame because so far they have nothing in common. As a result, everything is visually clear here. At fixing points to the bottom and strut mounts, reinforced platforms were made of thick metal. In the end, we attached the pipe to the back. It will replace a piece of spar and body. The only place that we didn't have time to finish was the base of the pillars. They need to be honed. A bit of sheet metal angle grinder and tack weld. After 2 Valera hours, one side is ready, but Andre had to do the second one. As a result, it looks like this. The next step is to prime the frame. First, we thoroughly degrease it. We dilute a bit of black primer, stir it well, and we can get to work. As you may have noticed, the guys often work without respirators, and the cameraman is no exception. This is how the whole process looks from the outside after an hour of painting without a respirator. By that time, the safety cage has already dried up 10 times, and we can do another fitting.
This is another fitting of our shell to understand what problems we can face in the future. And this is that our Bugatti sill is much higher and it's a little wider than that of Ford. We have 15 centimeters of space that we need to fill with something. This is exactly where the fiberglass shell of the sill is joined to the metal body of a Ford.
This will be the basis for future sills. It remains only to cut and install it in the body. To get this panel as close to the doorway as possible, we had to fiddle around with it. We saw the sheet of metal in some places along. We also make a lot of incisions in the places where we'll bend it. We adjust it, try it on, and so many times. When the mold is fitted to the opening, we are ready to weld it. As you understand, the solvent vapors have not yet disappeared, and the cameraman sees the garage exactly like this. As a result, it took about 6 Valera hours and 2 cutting discs to adjust the door sill. At this stage before welding, we need to sand the body in those places where the metal will be welded, since in the future we will have no access to the inside of this box, so we prime it in advance with zinc primer or weld-through primer. What's the point in removing paint and applying primer? The thing is that the temperature is very high at the welding points and the usual coating burns out. Accordingly, the metal is exposed and we have corrosion inside the box. But a special primer is not subject to these provocations and holds firm even at this temperature. Something like that. The next step is to assemble the already primed puzzle. Well, further work on adjusting the door sill is on your screen. Valera clearly measured everything, adjusted it, hammered it, and in 3 Valera hours we have such a box, which as a result is welded on all sides with reliable and thick metal. In the final, we cut off the jointing edge, which we made with a margin. We prime it and have this beauty. We are adjusting the door. First we disassemble it and take out all the stuffing, glass guides, lock and a window lifter. Then we cut off the bottom of the door by eye, leaving a small margin. It is this part that prevents us from installing the door into a new narrower doorway. And finally, the first fitting. We watch, evaluate, understand what needs to be fixed and fix it. Then we try on the door again and that's what we get.
We made this new detail, we carefully implanted in here. It remains only to give it the right curve, and we'll get a completely new bottom of the door.
As a result, that's exactly what we did. We fitted a beautiful new panel around the entire perimeter, cut it a little, bent it, and minted it. Roughly fixed it with screws, and the next Andre day after welding, we have such a picture which in principle we are very pleased with. Okay, the main issue is that the doorway of Volga is 35 inches. So the lining is the same. But in our project, in the concept, the door is twice as long. And if we use 2 linings, we can't work with this part. So, we have to be smart. For that we took 2 Volga door linings, and using improvised means we put it in the same plane. Thank God, the form is really simple and the horizontal line goes straight without any deviations, curves, and transitions. In the end, we have the right form of the door lining. The stock Volga has the same lining but twice as long. We stick metallized duct tape on every hole and joint. In the end, we have this panel. We measure it, and after that we'll recreate this piece using fiberglass. We're gonna do this according to the old pattern. First we use the release agent, then the gel coat, a few layers of glass mat, soaked in polyester, and after half an Andre day we completed the matrix. It looks like this. The next step is to fit the door trim. To do this we cut it off, put it on the body and fix it on the spot. Then we go to the Volga donor to remove the door handle. In the final version, the door will be a little shorter, and behind it there will be an air intake as in the original Bugatti. In the end, we were satisfied with it. And this means that we can fix it for good. In order for the fiberglass lining on the door to be fixed on well, we need to modify the upper part of the Ford door. With the help of a simple device and a Chelyabinsk marker, this panel is made, it's welded into its place, and we proceed to the handle. You can see it yourself. We cut out the hole, and after a few Valera hours we managed to cross the lever mechanism of the door lock with the handle from the Volga with the help of this thing. As a result, everything works fine, it opens and closes.
But now we are faced with a question that we need to raise the window, and the original glass does not fit here anymore, since our original mechanism will not enter either, because our door is shorter. So, this is what we did. First, the mechanism was disassembled, extra bits were cut off, and long hours of fitting began. In general, we adjusted the window lifter guides to our required size. Now the next step is to make a pattern for our future glass, since this original glass does not fit our doorway. And we need to make a new glass.
First of all, we decided to make a pattern of the future glass from plexiglass, and in the future to give this sample to production for the manufacture of normal glass. A suitable cardboard was cut out, transferred to plexiglass, cut along the contour with a grinder, fixed to the mechanism and put in place. And it became clear that when opening and closing the glass will rest against the visor of the Bugatti case. With the help of a pipe bend, this arc was made. As a result, we have a limiter. The glass will be attached to it in the future. Now it remains to make the right pattern.
Here, on the table we see glass from our Bugatti and a donor from which we will try to make a template for the further manufacture of new glass. See that it's straight. This is plexiglass, it gives into molding very well but at a certain temperature. Now we are trying to connect say two improvised glasses together so that our plexiglass takes the form of glass from Bugatti, but to do this we will first prepare everything and put them together. Judging by what we see, I think the experiment was a success. The form has acquired the features we need. You can see immediately that the desired radius has been achieved. In general, plexiglass completely covered our original glass.
We're slowly getting to the front panel matrix, the fenders, and the hood. Eventually we will replace this tired metal with fresh lightweight and strong fiberglass. For this we remove the decorative elements, clean up the rust, and start polishing. Since this paint looks very questionable and can eventually cause troubles, we remove it as much as possible. After 10 Valera hours we have a clean surface, on which we can apply pounds of putty and start shaping it. After all the old paint, primer and putty have been removed, we degrease the surface and throw on kilogram after kilogram of putty. So what is this done for? The fact is that the bodywork of the Volga even came out of the factory not quite smooth, not to mention the traces of 60 years of service. And besides, we have significantly changed the shape. Despite the fact that the splashboard will eventually be brought to an ideal, this won't work because all technologies are breached here. And this quantity of putty will definitely make itself known. That is why we will make these elements from fiberglass in the same way as we did the back of the Bugatti.
When we sharpen the splashboard, we don't forget to regularly estimate what kind of hinged elements there are. A lot of attention should be paid to fitting. By the way, it is convenient to putty right on the spot. We glue the headlight with masking tape and putty right on it, then we will immediately have a guide to the beacon how many putties we need to put on this sculpture.
We sharpen everything that is in the garage at hand. Flexible planes, inflexible planes, some kind of bars. You can even wrap the ruler which was used to putty in sandpaper. It is also convenient to sharpen with it. We sharpen it for development. As we said earlier, we will pile kilograms of putty on the old panels from the Volga, bring the shape to the ideal. In the future we will remove the matrices from them and make new fiberglass parts. As a result we will get light, strong, beautiful body panels with the correct geometry. But not everything is so simple and fast. And this work took more than 100 months. We continue to putty our sculpture. Alternate the direction of spreading the putty. That is, if we pulled one layer across the hood, then we pull the next layer along the hood to cover these furrows which are formed during puttying. By the way, a very cool putty with a color indicator. Initially it is blue, and then, during the reaction, it changes its color. And it is very clearly seen that there is no need to hurry. And it's very cool that it is clearly visible that you should not start grinding the putty. And when the putty has already fully polymerized, the curing reaction has ended, the blueness completely disappears. The blueness is completely gone. The curing reaction is over, it already becomes white, which means that you can already start grinding it. When the hood is primed starting from it, we make the right gap. That is, its fit to the wings. With a grinder we remove everything extra, we take off the wings, and then the exact same process as with the hood. Kilograms of primer, kilometers of sandpaper, André after André, and coat. As a result, we have an ideal shape. First of all, we pulled the shape of the bumper from the 3D model, cut it into plates, and cut these plates using a CNC made of expanded polystyrene. Then we assembled the constructor, which was disassembled, into 3D models and got a copy of the Bugatti Chiron bumper, although made of foam. We put this foam mold into the body and with the help of putty brought the mold to its proper condition. The next step was to put several layers of glass wool on the putty mold and get a matrix with which we will make a fiberglass bumper. Or rather, Valero will make it. Actually, his entrance. So, finally we filled up our bumper. Let's run through. We applied separation wax to the blank. After that we applied this is how the final fill looks like, but that's not all. We have to divide it all now, and I'll tell you it's not that easy. Meanwhile, Valera is busy with the rear bumper. In the original Bugatti, there is such a wing which opens and changes its angle. According to its shape we adjust the bumper. We cut off all the excess and attach it to the main body. In fact, it's not even a bumper, it's part of the body since Bugatti has a one-piece design. We did it separately because it's easier to make a part that way. Well, now it remains to combine it. Here we decided not to bother too much and just screw it on the screws. And for reliability, tape it up, which is what you can see. Of course it's a joke. These are just temporary holders for positioning, and the adhesive tape is needed so that the resin does not leak from the joints, since we will connect these two parts with glass wool. After the resin dried, we began in a hurry to prepare the whole body for rough painting. A couple of months ago I promised the guys to roll out the intermediate result of Bugatti to a local car company called Location. And of course, according to the best traditions, we finished painting and assembling at night a couple of hours before departure. The first thing they did was the main body. The old paint was removed with a solvent. By the way, these things perfectly played the role of coat. This is such a thin layer of paint or special powder so that it can be seen where the surface has already been sanded and where more work needs to be done. Also, the coat penetrates into all the recesses, flaws and traces of rough sandpaper, and after grinding these places stand out in contrast. Unless of course the color of the coat is radically different from the color of the part. That is why I apply a dark coat to a light detail. And then a couple of hours of grinding and we can paint. By the way, these particular shots were shot 15 hours before departure. So everyone who was in the workshop had to pick up some sandpaper. Before painting the doors, hood, and wings, we put them on the body, checked that they more or less fit together, and immediately attached the door handle from the Volga. When all the body panels are fitted, you can start painting. Andre conjured a little here, added a little varnish to the ground. And looking ahead, I will say that it gave a very cool effect. Put the first layer of white soil. It will also be a substrate for red paint. Once again I repeat, this is a rough painting, only to visually divide the car into two colors as in the concept and get to the event. So the front part will be white. We will leave it just primed. But the rear part, the half of the Bugatti, will be painted red. The best way to help us is to like, press the bell, and of course, subscribe.